So clip note number 40 reminds us about slope fields. One of the things that we can do is substitute ordered pairs into the derivative to compute slope values at those points and see if the little short slope segment's going in the direction that we need it to match the number. Another thing that we're sometimes asked to do is to actually create a slope field to construct those short line segments on certain ordered pairs. And then we're also asked to sketch the curve using the initial condition and guided by the tangent lines. So those are some of the things that we're asked to do with regard to slope fields. All right, we're asked to consider this derivative. On the axis provided, sketch a slope field for the given differential equation derivative at the 12 points indicated. Okay, so you guys can, just start working your way through these ordered pairs. I think I'll just start on the x-axis. So it didn't give me any guideline as far as what the scaling is, so I'm just going to assume this is -1, 0. Let me pull the screen down too so we can see that derivative again. Oh, there we go. That's going to be kind of hard. Okay, everywhere I see x, plug in -1, square it, that's +1. And now I'm going to plug in 0 for y and get -1. So that product is -1. So I'm going to draw a short slope segment that matches the slope of -1. All right, let me try 0, 0. X is 0, y is 0. So when x is 0, it doesn't matter what this is. I'm going to get a 0 slope, so I'm going to have a horizontal tangent line. At +1, 0, I'm going to get the same thing that I had at -1, 0 because I'm squaring my x. All right, now I'm going to work my way up the y-axis. All these x's are zeros. So if you wanted to label the point, that might be helpful. And you can see the visual of xy, xy, xy. And when you go to the derivative, when x is 0, again, it doesn't matter what y is, the product's going to be 0. So all of these tangent lines right here, these short slope segments, should be 0 slopes, horizontal. Okay, I guess I'll just work my way up here. This ordered pair is -1, 1, so when x is -1, square it, you get +1. But notice y is 1, and when y is 1, anytime y is 1, you're going to get a 0 out of this quantity. So your slope is going to be 0. So anytime, again, think about that. Anytime y is 1, you're subtracting, you're going to get a 0. So I can come over here immediately and draw in a horizontal tangent line. Right, evaluate the derivative at -1, 2. So that's going to be 1 times 2 minus 1 is 1. That's going to be a slope of 1. Now when I plug in -1, 3, -1 squared is 1, 3 minus 1 is 2, so that's going to become more steep. So what I should see is that in relationship to this slope right here, this slope should be more steep. All right, and 2 more. All right, and if we're kind of paying attention to the patterns, it doesn't matter what x is as far as positive or negative, because the effect in the differential is that we're squaring it. Okay, so this is going to be actually the same slope as what I had here, +1, and then here, when you plug the values in, it is going to match this slope right here. All right, let's look at part B of that same question. Okay, describe all points, not just these right here, all points in the xy plane, okay, the whole thing, for which the slopes are positive. Okay, I'm going to put the differential back down here just to have it in front of me. All right, so what has to be true in order for me to get a positive number? Well, one thing's for certain, x can't be 0, because if x is 0, I don't get a positive number. And then in order for me to get a positive slope, well, think back up here and what happened. When I fell below 1, I had a negative slope. When I had a y value of 1, when I say fall below 1, I mean when y was 1. When y was 1, I had a 0 slope. So anytime my y value was greater than 1, I would get a positive slope. And that makes sense right here. Either x squared isn't equal to 0 or y minus 1 must be greater than 0. So that must mean that y's value has to be bigger than 1. I have to be on a point on the graph whose y value is bigger than 1 as long as x is not 0. Then I would get a positive slope. Okay, sometimes you're asked, let me go back to that, sometimes you're asked to, after you create a slope field, you're asked to draw in a solution curve, and they might say through a certain point. So, I mean, just kind of be on the lookout for that to draw in a solution curve. This one doesn't really lend itself to that kind of question. There's really no kind of pattern here. Lots of times they'll just give you a finished slope field and say draw in the solution curve, which means just, again, just be guided by the slopes. Follow the direction. All right, part C. All right, find the particular solution. Find the particular solution. What's wrong with this pen? Put it in y equals format to the given derivative. That word solution needs to mean to us, if they give me dy dx, that the solution is y. The regular equation, y, and that means integration. To go back from y prime to y, you have to integrate. Observe that you have a combination of x's and y's, and so we're going to have to do a separation of variables. Sometimes this is not factored for you, and so you need to pull the x squared out. We're going to leave the x squared here, and we're going to divide both sides by y minus 1. Okay, we will be using that point at some time. Okay, we're going to bring in the integral symbol. This requires a U-substitution. You can bring this out of the denominator as y minus 1 to the negative 1, or you can leave it in the denominator. And notice that it's going to go back to a natural log. I don't have to bring anything. This just becomes du over u. Okay, this is x, this is y. 3 minus 1, which is 2. X is 0, so c is ln of 2. Curse them, they want me to put it in y equals format. So bring in an e. I'm going to separate so that I have two bases of e, just because I have a constant part right here. And when I notice that the ln is there, I know it's going to simplify nicely. It's going to be a 2 multiplier in front, not a plus 2. But remember, both bases with e require a multiplication, so I can add these exponents and get back here. All right, I'm going to remove the absolute value, but that means I need a plus minus. I'm going to put the 2 that's left up front. Thank you, Brittany, for that. All right, so I have a plus minus. I'm going to add a 1. Okay, and now which one to choose, the plus or the minus? It's all about that initial condition. Remember what it was? So we use this twice. Okay, plug in, this is X, this is Y. It's probably going to be the plus solution. If X is 0, this all goes to 0, this is 1, so I need to do 1 plus 2 in order to get the 3. So through your work, you should show both plus and minus. And then I just write down the correct solution that I'm choosing last. So that's a solution to that differential equation that we started with here. After correctly separating the variables, integrating, this is a pretty complicated problem. Okay, looking back, I don't think I answered the full question. It says draw in the solution. All right, so let me go to 0, 3. Right here. And using the slope segments as a guide. Oh, 0, 3. It's exponential. So they probably, okay, I'm kind of surprised they want you to draw this, but I guess not so much now that we found the solution here. We don't have a lot to go off of from here. Okay, so I guess I'll just try and make the graph from the left. So I think when I leave this tangent line right here, okay, it's kind of horizontal, but I'm going to have to drop down and now follow this slope segment. And the further you travel to the left off the screen, these are all going to be horizontal tangents. So I guess I'm going to have a horizontal asymptote. The graph's going to go something like that. Okay, and what's interesting here is when I leave to the right, okay, at some point I'm going to be guided by more steep slopes. The slopes of the graph is going to be more steep in this kind of format. I don't know. That's what these slope segments are suggesting to me. Pick up a calculator. Type that into Y1 if you're curious. Okay, I'd pick it up and look at it. All right, so it's a review of slope fields.